Timelines are an incredibly useful tool inside of Unreal Engine. They give you the ability to quickly and easily add animated behavior to a variety of things. While they're primarily meant to be used for simple animations, they are useful for a lot of tasks. Some of the common uses of timelines are creating recoil patterns, automating lights and material colors, controlling day-night cycles, and most commonly animating static meshes such as buttons, levers, and doors. So without further ado, let's jump right in and look at some of these examples. So here we are in a first-person template, and I have a few things set up here using timelines. As you can see, we have this moving platform. We have a very simple door that if I walk up to it, it's going to open and play a sound, and then when I leave its proximity, it's going to close and play a different sound. And then we have this light that is just switching between red and blue. And we're going to cover how to make each of these in this video, but before we do, let's just make a basic actor, and we're going to call it timeline example, and we're just going to have a look at the timeline node itself. So I'm going to open this, and we're going to go to the event graph. Now, to create a timeline, what you do is you right click, if you type in timeline, you'll see you get this option to add timeline, and it's a little different than other nodes, so let's add it, and you're going to see we get prompted to change its name. So I'm just going to call this example timeline. And I want you to notice that it creates a component variable over here that I can drag out. And the first difference between the timeline node and other nodes is that this is actually treated as a component inside of an actor. It doesn't show up in our components panel, but we do have a component variable that stores all the values related to this timeline, and we can use this to do a whole bunch of things during runtime, which we'll look at that a little bit later. Let's just look at the timeline node for now. It may look intimidating, it's got a lot of different pins, but it's actually really straightforward to use. So to get started using this timeline, what we're going to do is we're going to double click, and you're going to see that it opens a new tab inside of our blueprint, which again is different than most other nodes. But in here is where we're going to have all of our track settings, and this is where we're going to add curves and other things for the timeline to use. So if I click new track, you're going to see we have a few different options here. Let's just start with a flow track. And once I create that flow track, you're going to see we now have this curve that we can edit right inside of Blueprint, and it's prompting us to give it a name. So I'm just going to call this float track. Or as a matter of fact, to make it clear, I'm going to call it my float track. And before I do anything, I'm going to go back to the event graph, and I want you to notice that it creates a pin for that float track. So if I go in here and I add another float track, you're going to see it now outputs 2 floats. Let's click on this and delete this for now. And what we're going to do is we're going to add some keyframes to this float track. So I'm going to right click right here. We're going to click add key to curve float _0. And then you'll see we get these values up here. We can set the time. So I'm going to set it to 0, 0 for this first keyframe. And then I'm going to right click and add another keyframe, and I'm going to set the time to 1 and the value to 1. And that didn't work for some reason. There we go. And you're going to see it goes off screen here. So we can scroll to zoom in and out, and we can right click, hold, and drag to pan around. Now, if we want to fit this perfectly to the screen, we have these 2 buttons here. We have zoom to fit horizontal and zoom to fit vertical, and now the curve is fit perfectly on the screen. So this will do pretty much what you probably expected to do. It's going to play over a duration of 1 second and output values ranging from 0 to 1 over that second. Now, at the moment, the length of our timeline is actually set to 5. So this would actually play for 5 seconds. It would get to 1, and then it would just sit there until it gets to 5 seconds. Let's change the length of our timeline down to 1. Okay. So to demonstrate this, what we're going to do is we're going to print string, and we're just going to print out that float. Now the updated pin, as you could probably guess, is going to run every time this ticks. Now, as this currently stands, nothing's going to happen because we're not telling it to run. And you can see there's a lot of different ways to tell this to run, but there's actually an even simpler way in this case. So up here, we have a few different options, and one of them is autoplay. If I click this and go back to the event graph, you're going to see it now has this little icon here. And each one of these will add a new icon to the top of the node. So if I click loop, for example, you'll see we now have 2 new icons up here. And those are just useful so you know what's going on with the timeline node. So I'm going to turn off loop. I'm going to keep autoplay on, which means that this is going to run as soon as the game starts. Now, obviously, we have to drag this timeline example into our world. And if I hit play, you're going to see over the course of 1 second, it prints out a float that smoothly transitions from 0 to 1. Now you might also notice that we have this finished pin here, and I'm sure you can guess what this does. It's going to run when the timeline finishes. So if I go in here and I do a print string and type timeline finished, and then we compile and hit play, you see at the end it says timeline finished. And we also get this direction enum, which we can use to switch and determine if the timeline is going forward or backwards. We'll have a deeper look at this later when we get to the door. And then we have all these pins here. Now let's just start with the play pin. Let's go in and let's turn off autoplay. And if I do that, you're going to see it no longer prints out because nothing's telling this timeline to run. And what I'm going to do is on begin play, I'm just going to call play. And you're going to see it plays just like before. And there are a lot of scenarios where doing this as opposed to autoplay is much more useful. Although we're using begin play here, you may not want your timeline to just run at the beginning. You may want to trigger it at some point down the line in your game. So that's why these pins are super useful. And you might be wondering, what is play from start and what's the difference between it and play? Well, again, we'll demonstrate this further on when we get to our door. But in a nutshell, you'll see we have play, reverse, and then play from start and reverse from end. So say the timeline's playing forward and it's at a value of 0.5, and then we call reverse. It's going to start wherever it is and go backwards. Whereas if we were to call reverse from end, it's going to jump to the end of the timeline and then go backwards. So we're going to take a look at that in just a second. But before we move on to creating all the examples in the level, I just want to show you a few more of these settings up here. So we saw autoplay, and we also have a loop, which again, will do exactly what you expect. It's just going to loop over and over and over again. And this is incredibly useful in a lot of scenarios. We also have a replicated button if we're dealing with multiplayer. Ignore time dilation, which will ignore, I believe, changes to the tick rate in the level. We have our tick group, which we're not going to get too deep into which each of these mean. It's a little bit outside of the scope of this tutorial. I suggest you look into what the different tick groups are. Normally, I leave this on pre-physics. And then we have this use last keyframe button. Now, I'm going to be honest, I never really notice any difference when I use this. So in this case, for example, I'm turning off loop. And if I turn it on and hit play, you're going to see it ends on 1. If I turn it off now and hit play, it still ends on 1. I'm not sure what the deal with that is. If anyone knows, let me know in the comments down below. I've never really noticed a difference when turning that on or off. Okay, and yeah, and as you saw, we can also add a variety of other tracks. We can add a vector track, and they're all pretty self-explanatory. I'll go in here and call this my vector, and in here, we can add key and values to all curves, because with a vector track, we get 3 curves, 1 for the X, 1 for the Y, 1 for the Z. And this will do exactly what you would think. We have a vector output here now. And if I were to print this out, you'll see that it lerps over those values. I honestly don't find myself using the vector track that much, if at all. The other ones I've used pretty heavily, but not really the vector track. I can usually achieve most of what I'm trying to do with the float track. So that's not to say don't use it or that there's anything wrong with using it. I just personally don't find myself using it a lot. And then aside from vector tracks, we have color tracks, which we can create a sort of gradient to lerp over. So if I set this to blue and then click here and set this to orange, I accidentally added another keyframe. To add and delete these, you just select one, you can click delete. And to add a new one, if you click in this area right here, it'll add a new one. Although I've used this one before, I don't use it that commonly, but it does have some good uses like automating lights and material parameters, which we'll have a look at the light examples shortly. And then finally, we have an event track. Now this one I do use a lot. And if we add a keyframe in here, we'll call this my event track. If I go back to the event graph, you're going to see that this shows up as an execution pin, and this can be incredibly useful in a lot of cases. Now, as far as I know, the actual value of this keyframe doesn't matter. That is where it is on the y-axis. It really only pays attention to the time as far as I know. And yeah, you can now see an output for each of those tracks that we added. We have our float, our vector, our color, and then that event track. And we can add more than one of each of these. I could go in and add another event track. And you'll see we get another event track. Now it's getting kind of messy in here. I'm just going to delete everything. And finally, there's one other option in here, and that's add selected curve asset. Now, I don't typically add custom curves this way. I do use custom curves with timelines, but I'll show you if I go into our content browser and we go to, I believe, miscellaneous, and then we have a curve. We'll create a float curve and we'll just call it my custom float curve. With it selected, I'm supposed to be able to go in here. You can see it's not grayed out anymore, but you'll see nothing happens. And I've noticed it's kind of buggy like this. I'm not really sure why. If I delete this and then I try doing that again, now it's added. But yeah, it sometimes behaves weird. The better way, in my opinion, is to just add a float track and then go in and select the curve you want to use. And when you do so let's real quick go into the content browser. I'm just going to add some keyframes here. Like that. And my custom float curve. You're going to see we have those keys in here, but we can't actually edit them directly in here. In order to edit them, we have to go to the curve asset that we created. And you'll see that it updates. So as I mentioned before, we have a component reference to this timeline, and we can do a bunch of useful things with this during runtime. So if I drag off of here, if we go down to components and then timeline, you can see we have all kinds of different functions and whatnot that we can call for this timeline. I'm not going to go through all of them, but basically all of these pins, we can set custom curves on the fly. We can set the play rate. Pretty much add any track that we want, change whether or not it's looping, check if it's reversing, all kinds of different stuff that's really useful in a lot of different scenarios. For example, being able to add a custom curve on the fly is extremely useful, especially if you were to be making something like a weapon system and you were using this for a recoil pattern. What you could do is you could have a base gun class, and then you could have a timeline that does all the logic of changing the player's yaw and pitch and all that stuff. And then on that parent class, you could have a custom curve that gets set on a function that you could call from each child and add in based on how you want their recoil to behave. We're not going to look at that in this video. That's a tutorial for another day. It's a bit out of the scope of just basic timeline behavior, but it is a very useful aspect of timelines to know about nonetheless. So we're going to hop out of here now, and we're going to go and create each of the examples that I've showed you at the beginning of the video from scratch. All right, so I've cleared everything out of my project. Let's start with the simplest one, which is going to be the lamp. So we're going to create an actor, and we're going to call it BP underscore lamp. And maybe we're making a siren or something like that. But in here, we'll add a static mesh, and we'll just use the default lamp static mesh that comes with the starter content. And we'll add in a point light. Okay, I'll just drag this point light up a little bit. I'll set its intensity a little lower to like 1000. And then we'll go in here. We will create a new timeline. And we will call this light color timeline. All right, and then we'll just click on it. We'll add a color track. We'll call this light color. And then what I'll do is I'll select this first keyframe here, double click, and I'll just set the let's set the red value to 1. Then we'll click this last keyframe. We will also set this to a red value of 1. That way it starts and stops on the same value. We'll set it to looping. And then in the middle here, we'll add another keyframe and we'll turn the blue all the way up and the red all the way down. And one thing that's kind of annoying is I don't have the boxes that let me set the time directly. So I kind of just have to eyeball it here as far as I know. But that should do for this anyways. Now we're going to grab our point light component and we're going to do set light color. We'll go here. We'll set it on update and we'll plug in that light color pin. So if I compile, drag this into the world. I'm just going to mount it up right here. And I hit play. Nothing's happening. And that is because I accidentally set this to loop, but didn't set autoplay. So now if I hit play, you'll see that it's changing color and it's stopping on red because, again, I didn't change the timeline time. So let's set this down to 1. And now, I don't know where this came from. Let's delete that. It'll go from red to blue, back to red, and then loop over the course of 1 second. So if I hit play, there it is. Okay, great. And that's our point light done. So now let's make the door. And this is a very common thing to do with timelines. The way I'm going to be doing it in this video is super simplified. So I'm going to be just using a collision and triggering it that way. I would never make an actual door that way. I would make some kind of interaction system, as I've done in other videos like my interface video. But I'm not going to do that in this video for the sake of simplicity. So what we're going to do is we're going to add a static mesh. Call this one door frame. And then we're going to set it to we're going to use the door meshes that come with the starter content. So there's the frame. We're going to add another static mesh. And this one is going to be the door. So we'll go in here, type door. Okay, and we'll just eyeball it for now and put it into place. And then I'm going to add a box collision. And I don't want this parented to the door. We can parent it to the door frame like so. And I'm just going to position it, change its box extent here like so. Okay, great. Now in the event graph, we'll just delete all this. We're going to select the box in the components panel, and we're going to add an event. We're going to add onComponent begin overlap, and then we're going to add an onComponent end overlap. And we're going to cast to the first person character so that we know that it's the first person character that's overlapping and leaving the collision and not just some random object in the world. And then we will create our timeline, and we'll call this door timeline. Now, there's a few different ways that you can go about doing this. Again, I'm going to do it the simplest way. I'm going to go in here. I'm going to add a float track. I'm going to call this alpha. I'm going to set the length to 1. And then we're going to add a key, and we're going to set it to 0, 0, and add another key, set it to 1, 1. We'll fit the view to screen. I'll select this keyframe and then shift click this keyframe, and then we will right click and we'll click auto, and that's the key interpolation, so you can see it smooths out there. You can, just like with any curve, you can go in and you can edit these tangent handles and change how the curve interpolates, but we're just going to set it to auto so it's nice and smooth. We'll compile, go back into the event graph. You see we get that alpha output. So what we'll do is we'll grab our door and we're going to set relative rotation. We'll split this struct pin, and on update, what we want to do is we want to multiply this by whatever we want the max rotation to be. So in practice, what you would probably do is create a variable here that would be max offset and set it to some value on a case by case basis. In this case, I'm just going to set it to 90. And we're going to plug that into the Z. And if you think about it, when this value is 0, it's going to multiply 0 by 90. So the door's rotation on the Z is going to be 0, which is closed. Then, it's going to make its way up to 1. Let's say it's at 0.5. 0.5 times 90 is going to be 45. So it's going to be halfway between closed and open. And when it gets to 1, 1 times 90 is 90. It's going to be rotated at a 90-degree angle. And if we reverse it, the logic applies the exact same in reverse, going back to 0. So when we overlap with the box, we are going to play. And when we end overlap, we're going to reverse. You might be wondering why we did play and not play from start and reverse from end. We'll have a look at that in a minute, but real quick, let's bring our door in. Let's hit play. And I accidentally did that to the door frame, which we don't want. We want to do it to the door. So now we walk up, the door opens, we walk away, the door closes. Now, why don't we want to play from start and reverse from end? Well, let's do that real quick and let's see what happens. So at first glance, it doesn't seem like there's any difference, but if I walk up and then walk away, notice how it snaps to the end and then closes. Whereas if I just do reverse and play, you're going to see that if I leave midway through the animation, it starts reversing from where it was already at. So hopefully that's clear what the difference between those pins are. Now, as you saw in the beginning of this video, I had sounds on this door, and I think now would be a good time to demonstrate one of the many uses of the event track. So we're going to add an event track, and we're going to call it play door sound. And I'm just going to add a key. I'm going to add it a little after the very beginning, like so. I find that doing so usually looks and feels a bit better. And it also depends on your sounds. Some sounds for doors, like it's like a creaking and then a shut, so you might want to set it appropriately so that the actual slamming shut sound lines up properly. In this case, I'm going to be using some assets I got from the marketplace. You can use any sounds you want. It's not a big deal. But what we're going to do is we're going to come off this direction enum, and we're going to do a switch. And we're going to plug this play door sound on, because we have this right here at the very beginning. So when we hit this coming from one direction, we want to play an open sound. And when we hit it coming from the other direction, we want to play a closed sound. So what we're going to do is we're going to play sound at location. We'll get our door and we'll get the world location. Plug that in like so. And I'm just going to come in here, search for one of those assets. So when we're moving forward, we want to play an open sound. So I'll choose this door common open. And then when we're moving backwards, we're going to want to play a closed sound. We'll do that one. And now if I hit play, it plays an open sound and it plays a closed sound. And yeah, that's really all there is to the door in this case. Again, this is a very, very simple setup for a door. There's so much more that you could do with this. You could make the door always open away from the player. You could have different rotation amounts. You could implement an entire interaction interface. But again, that's outside of the scope of this tutorial. I just want to focus on timelines. All right, so finally, I'm going to create the platform, and I'm going to use the platform to demonstrate more of the functionality of the timeline. So let's go in, create a new actor, and we're going to call it BP_platform. All right, we'll add a cube, and let's just size this down on the Z. Great. Now let's come in here and let's create a new timeline, and we will call this our platform timeline. And we're going to open this up. We're going to add a new float track. I'm going to call this offset alpha. And we're going to set this to a value of 2.5. I want it to last 5 seconds in total, but you're going to see why we're doing this. So I'm going to add this keyframe in at 0, 0. And I'm going to add another keyframe, and it's going to be at 2.5 and 1. And we'll fit this to screen, select both keyframes, and select auto. So what we're going to do is we're going to go back to event graph, and we're going to start this node on begin play. We'll grab our cube, and we will set its relative location. Split the struct pin, and we will plug this into the Y, or no, I'm sorry. What we're going to do is pretty much the same thing for the door. We're going to multiply it by some offset. In this case, it's not a rotation, it's a linear offset. We'll set it to 300. We'll plug it into the Y, and then we'll plug this into update. And if I compile and I hit play, well, I better add it to the world first. you'll see that it moves over 300 units. I should probably move it over a bit because it clips to the door, but it stops at the end. Now, we don't want that. We want it to move over that 300 units and then move back. So how can we achieve this? Well, first let me move this over here so that it stops clipping with the door. Move the door over too. So what we're going to want to do is on finished, we're going to want to call a custom event, but before we can even do that, we have to determine which direction we're moving in. So we're going to switch on the timeline direction, and on finished, if we're moving forward, we're going to create a custom event, and we're going to call it reverse platform, and we will plug this into reverse. Now, instead of doing this on begin play, what we're going to do is create a custom event, move platform forward, and let's rename this so that it's consistent to move platform back. Plug that into play, and then on begin play, we'll call move platform forward, like so. And now, when we're moving forward and the timeline finishes, we'll call move platform back and move platform forward. Compile. If I hit play, you'll see it gets to the end, and it just basically loops back and forth. And this is just another way to make looping behavior that can be extremely useful in a lot of different cases. Now, one more thing, I want to demonstrate this new time variable here. So the timeline's total time is 2.5 seconds, and then it reverses. Let's just say we wanted it to start halfway between that. So as a matter of fact, to make the math a little bit easier, we're going to set the total time to 2, and we're going to bring this value to a time of 2. So now it's just going to last 4 seconds in total. Now, if I go in here and I do something like set this to 1, and I compile and I hit play, nothing's going to happen, because anytime we want to use this new time variable, we have to call this. So what we're going to do is on begin play, we're going to add a sequence node. And we're going to call this, and then we're going to set that new time. And now you should notice it's not going to start right here. It's going to snap to about the middle. And there's that new time. Now, a specific instance where this is incredibly useful is when making day-night cycles. You can do some math and you can set this up in a way that you have the ability to set the start time of your day-night cycle for your game, and it's incredibly powerful and incredibly useful to do. In a future tutorial, when I make a day-night cycle, I'll be demonstrating how to do that. But yeah, that's pretty much all for this video, guys. I hope you enjoyed. If you have any questions, comments, or concerns, leave them in the comments down below. If you like this video, please consider slapping a like on it. And for more content from me, consider subscribing. I wish you all the best of luck in your projects.